All right, if you're in healthcare, you know our world runs on data. But let's be real, you also know that data is almost never perfect. So in this explainer, we're going to tackle a huge challenge, one that you probably face every single day. What do you do when the data you need just isn't there?
I love this quote because it just hits the nail on the head. We hear all the time that data is the new oil. But in medicine, man, it's crude oil. It's not like the clean, neat data you might see in finance. Nope. Our data is raw. It comes from, crazy busy workflows, a dozen different systems that don't talk to each other, and just real messy human situations. It needs a ton of refinement before it's actually useful.
And this is what that crude oil looks like in the wild. Just looking at this spreadsheet probably gives you a little bit of anxiety, right? You've got values with percentage signs that need to be stripped out. You've got your classic NA for missing entries, totally inconsistent formats all over the place. And look, this isn't some rare worst case scenario. This is the daily reality for so many of us working with clinical data. All right, so let's try to reframe how we think about this. Instead of seeing missing data as some kind of, failure or a bug in the system, let's think of it as a symptom, a really common symptom that you're going to see in pretty much every data set. And our job? It's not to just ignore it, it's to understand it, just like we would any other clinical sign. So what causes the symptom? Well, the reasons are all over the map. It could be something as simple as a typo during data entry, or maybe a piece of lab equipment was down for maintenance one day. We've all seen data get lost during a big system transfer, right? It could even be a patient who, for very personal reasons, decides not to answer a sensitive question. The main takeaway here is that there are tons of reasons these gaps show up. And this is where our clinical mindset really comes in handy. Because what's the first rule in medicine? You never, ever start a treatment without a diagnosis. It's the exact same thing with data. Before we even think about deleting rows or trying to fill in those gaps, we have to figure out why the data is missing. Seriously, this is the most critical step of the whole process. Now, you don't need to be a statistician to do this. We can actually start with 3 really simple but super powerful questions. Think of these as your diagnostic toolkit. They're going to guide you to the right strategy for dealing with all those empty cells. Okay, so those 3 questions we just talked about, well, they actually line up perfectly with the 3 official diagnoses for missing data. You might hear data scientists throw around these acronyms, MCAR, MAR, and MNAR. But don't worry about memorizing the letters. The important thing is that they give us a shared language to describe exactly what's going on. So, the first one is called Missing Completely at Random, or MCAR. And honestly, it's the simplest one to understand. It means the data is missing just because of pure random chance. It has nothing to do with anything else. Think about it. A lab machine goes down for an afternoon, or a batch of paper survey forms gets misplaced. The fact that that data is missing, it tells you absolutely nothing meaningful about the patient or their condition. It's just bad luck. Okay, next up is Missing at Random, or MAR. Now, this one is way more common, and the key difference here is that there is a pattern to the missing data. But, and this is the important part, you can explain that pattern using other information you already have in your data set. For instance, maybe you notice that follow-up labs are missed more often for your younger patients, or perhaps for patients who get admitted over a long weekend. See, it's not totally random, it's connected to something else that you can actually see and account for. And that brings us to the third and definitely the trickiest category. This one's called Missing Not at Random, or MNAR. Now this is where things get really interesting, because here the reason the data is missing is directly related to the value that you're missing. A perfect example is a weight scale that has a max limit, say 400 pounds. So if you see a missing weight value, it might be because that person's actual weight is over 400 pounds. In this case, the fact that the data is missing is actually a piece of information all by itself. All right, so we've asked our questions, we've made our diagnosis. Now what? Well, now it's time to talk about the treatment plan. And when it comes down to it, you really have 2 main paths you can take. You can either get rid of the incomplete data, or you can try to fill in the gaps. This workflow here is a great little roadmap for our options. You see those 2 big branches at the top, right? Deletions on one side, imputations on the other. Now, there are a bunch of different techniques under each one, but really it all starts with this fundamental choice between these 2 approaches. So what's the difference? Well, it's all about trade-offs. Deletion is easy, right? You just get rid of the problem rows. But the big risk is that you're shrinking your data set. And when you do that, you can lose what's called statistical power, which is just a fancy way of saying it gets harder to find a real, meaningful result. It can even introduce serious bias. Now, imputation, on the other hand, lets you keep all your patients in the study, which is great, but you always have to remember that the new number you're putting in there is an educated guess. It's not the real true value.
I really like this analogy. Think of imputation like you're putting together a jigsaw puzzle. You've got a missing piece, right? What do? You look at all the pieces around it, the colors, the shapes, to figure out what's supposed to go there. That's exactly what imputation does. The algorithms look at all the other data you have for that patient to make a really smart guess about what that missing value should be.
Okay, so we've walked through the diagnosis and the treatment options, but all of this leads to what I think is the most important point of all. The final call, it can't just be made by some algorithm. This is where you, with your clinical expertise, become absolutely essential. It's like your data science superpower.
Yeah, this quote absolutely nails it. A computer can spit out a number to fill in a blank, but can it tell you if that number actually makes sense in a real clinical context? No way. That takes domain expertise. That takes your expertise.
Think about it. An algorithm might suggest imputing a blood pressure of, say, 60/40 for a patient who is otherwise totally stable. You, as a clinician, would immediately know that's not plausible. Or you might see a pattern of missing follow-up labs, and your brain immediately connects that to patients who tend to leave against medical advice. The computer just sees an outlier. You see a potentially life-threatening lab value that needs to be addressed right now. That kind of judgment, it's completely irreplaceable.
So please remember this. The goal here is not to create some kind of magical, perfect data set. That just doesn't exist in the real world. The real goal is to be thoughtful, to be transparent, and to have a good rationale for how you handle the imperfections you're gonna find. It's all about making a series of smart, clinically informed decisions. So I'm gonna leave you with this one question. The next time you're staring at a spreadsheet and you see that empty cell, that NA, that little gap in the patient's record, just pause, just for a second. Instead of automatically hitting delete on that row, what's the first question you're gonna ask yourself? Because that simple shift in your thinking, well, that's the first real step to taking control of your data.